Okay, in my previous video, we have talked about how we can implement linear regression from Splunk MLTK experiments tab, right? What we have done, we have given a search, then based on that search, we have chosen our algorithm, that which is linear regression. Then we have selected the field which we want to predict, and based on which field we'll be using for prediction purpose. And also we did the event sampling as well, right? The number of records which will be used for training and test purposes, we have did that. Now everything, if you see it over here, that can be implemented using a custom command as well. Okay, so Splunk MLTK comes up with lot of custom commands which are basically used behind the scene over here. Okay, so in this video we'll deep dive into those commands. We'll see how those commands works, and literally whatever processing we are doing it over here, not the visualization part, mostly the processing part, we will see we can achieve it through those custom commands. Okay, so there are total 7 commands mainly important in this case. We have sample command, we have fit command, score command, apply, summary, list models, and delete models. Okay, so in this video we'll discuss all these commands except the score command, which is used for scoring the model accuracy. So when I'll be discussing the theory about the model accuracy, after that we will come back to this score command. Okay, so let us start. Now, as you remember from my previous video, I have indexed that graduate admission dataset into my main index, right? Now, let us table the columns. Okay, so mainly we are worrying about this GRE score, TOEFL score, university rating, blah blah blah, right? So now our job is to, if I just go by this particular screen, so logically after we have our initial data set, the first thing is we have to sample our data. This is called event sampling. Okay, so that means we need to determine how much of this data we will use for training purpose and how much of this data will be used for testing purpose. Okay, so that introduce to our first command called sample. Okay, so Splunk provides lot of options for sampling the data for training purpose. Okay, the first option is, the command name is sample. Okay, the first option is ratio, which determines, so if I give in the ratio, you can give a number less than 1, less than or equals to 1. Basically it gives us the probability of that particular event to be considered as a result set in the result set, right? So that means if I give ratio equals to 0.9, that means each and every record has 90% of chance to be selected as a final data set. Okay, so if I just go by simple math, that means Splunk will basically give you the 90% of the data of the whole record set. Okay, approximately. So let us apply this over here. So after our initial data set, we'll say sample. Okay, then ratio equals to, let's say, 0.7. That means each and every event has 70% of chance, right? Now I have total 500 events, right? It will nearly give me 70% of that 500 events. That means nearly 350 events it will give me. So it is giving me 341. It cannot give exactly one, so it's give approximately 350 events. Okay, so this is one way to sample your data, right? Now let's move on. Let's talk about count. Okay, now count is another input of sample, where it will give you the exact number of rows. If I just give count 300, that means it will give me exact 300 number of events. Simple enough. Let's move on. Now count you can do by another column. That means, let's say I have a research column over here, right? So it can be any column. So that means if I just give count equals to 100, okay, by research, let's say, okay, if you see it, research has only 0 and 1 value, because whether the student has done research or not, it just takes 0 and 1 value. So if I give count equals to 100 by research, that means it will it will take 100 rows from the value of 0. For each and every distinct value of research, it will take 100 rows. That means it will give me total 200 rows over here. 100 rows from 0 event, 100 rows from those events where research is equals to 0, again 100 rows from those events where research is equals to 1. To verify that, we can do one thing. We say where research equals to 0, right? So it will give me exactly 100 rows over here. If you see, all research equals to 0, then research equals to 1 also 100 rows. So this is how it will sample those events. Okay, now let's move on. Let's talk about, we talked about count by research. Let's talk about proportional. Okay, so sample has another input called proportional. Okay, now the proportional input, it basically takes a field name which is numeric in nature. Okay, so now what it will do, based on field values, it will determine the probability of that particular event to come up or not. For the best example, if I just give proportional equals to research, that means for each and every event, okay, so it will take that particular research field value as the probability of that event. And if you see, research has only 0 and 1 value, right? So that means the events which has research value equals to 1, it will have probability of 1. That means it will be always be selected. And those events which have research value equals to 0, it will have always probability 0. That means it will not be selected at all. Okay, if you see it here, so now see, it is only selected the events which has research value as 1. Okay, so this is how the professional input works. Now let's move on. Now here, proportional, you have another thing called inverse. Okay, so if I just give inverse over here, okay, what will happen? Inverse means the probability value, here what is happening, proportional, in the case of proportional, the field value itself is becoming the probability value. Inverse means it will be negative probability, that means 1 minus that probability value. Now in that case, what will happen? For events which has research value as 1, the probability will become 0, and where it is 0, the probability will become 1. So in this case, what will happen? It will select the rows which have research value as 0. This is exactly what is happening over here. Okay, so let's move on. Let's talk about partitions. Okay, so partition is another input over here. Okay, partitions, if it takes a numeric value, okay, any natural number. So if I just give partition equals to 3, what it will happen, it will divide this whole set of events into 3 different sets. Okay, now how it will determine, it's basically take a random number, and based on that random number, generates it generates the random number for each and every set, and assign those random number to them, and divide this whole events into 3 partitions, different partitions. If I just give partition is equals to 3, what will happen, that it will, if you see here, it creates a new column called partition underscore number. And if you see, the column value is 0, 1 or 2, right? So that means wherever it is 0, that means belongs to 0th partition. Wherever it's 1, it belongs to partition number 1. Similarly for partition number 2, right? So now if you see, it is doing this thing randomly over here, right? Because it is selecting its own random number. Now over here we can give another input called seed. Okay, now if you give seed, you are basically giving that random number over here. So what we are achieving here, so whenever we are giving seed, if we maintain the same seed value, the rows whichever previously was selected for zeroth partition, it will always be selected as zeroth partition itself. So this is how you have some kind of accuracy of selecting that record. Okay, but in terms of output, it is same. It is just like the similar row, the similar event has greater probability of staying in same partition. That is how the seed works. Okay, so now if you see, the partition is creating a new field called partition underscore number, right? Here you can change that name as well. So there is an input called field name. You can give any name over here. Let's say partition. So instead of creating the partition underscore number, it will create the column name as, or field name as, partition. Okay. So and then you can always work on a specific partition over here for training purpose, a specific partition for testing purpose. Okay, that is how it works. Now let's move on. Okay, so we almost talked about most of the stuff related to sample custom command. Okay, so that means by sample custom command, what we are achieving, we are achieving this guy over here. We are splitting the whole data set between a training and test data set. Okay, so we are selecting our data for training. So now the logical next step is to select how to fit the data, right, to that particular, how to fit that particular algorithm to our data, right? So that means we are basically going to discuss the fit command over here. Okay, so now this whole video we are discussing about in terms of linear regression only. So I'll be creating separate video for separate algorithm, okay, for the same set of commands, because the syntax, the way it works is little bit different from commands to commands. So our discussion will be very much limited to the corresponding algorithm we have discussed. Okay, so for fit command, so basically as the name suggests, it's basically creates that particular model, right, by applying that particular algorithm on our data, right? So this is the syntax. Okay, so now for this is the supervised, as we are linear regression is very much supervised in nature. So this is the supervised syntax of the fit command. So the command name is fit. Okay, then the algorithm, that means in this case it will be linear regression. Okay, then you will have lot of options over here, right? Now if I just tally over here with this particular screen, one of the option is the fit intercept, right, whether we want to estimate the intercept or not. So this is one of the inputs for our fit command, which is called fit underscore intercept, true or false. Okay, then it is our response field. So if I just tally it over here, it is the fields to predict, right, which field we want to predict, and from the explanatory field, that means which fields are used for other other features basically, except from the field we want to predict. So this guy over here, right? So this is our syntax. So let us see how we can apply this one. Okay, so for that what we'll do is we'll just say we'll make this two partitions. Okay, we'll sample this, or better let's say we'll take ratio equals to 0.9. Okay, 0.7, let's say. Now we have total 328 events which we'll be using for our training purpose. Then I'll say fit. Okay, then my algorithm name, which in this case it will be my linear regression, right? Now our options for that particular algorithm, right, which is case fit underscore intercept. There is another option called normalize, which will be discussed later. Fit underscore intercept equals to true. Okay, now we have to give the field which will be predicting, right? So in this case, for our case, it will be our chances of admit, right? So this is what I will be giving it over here, chances of admit. Then from, okay, the other fields, right, like this. So if I just run it, so it is happening in the behind the scene, it is happening, it is what is happening basically here, it is applying this whole linear regression algorithm to the data set I have it over here, right? So now fit has, if you see, it created similar kind of output over here. Whenever we have seen it over here, this predicted chance of admin, and the residuals, we created this particular algorithm, this particular experiment tab. Whenever we have done the fit model, it created these things, right? So similarly, these things also created over here. It did not create the residual. You can create it by your own, just it is just the actual value minus the predicted value. Okay, now if you remember from my previous video, when we save this particular model, it asked me for a model name, right? So that similar same thing can be achieved in fit as well with this into command. Okay, into input, basically you have to give a model name. Let's say I'll give test underscore model. Okay, so that means whatever actions we are taking it over here, it will be saved as a model called test underscore model. And if you remember from my previous video, the model is saved as a lookup file, right? So similarly, a lookup file also be created for this one. Okay, so we talked about our fit command, so let's move on. Okay, so score, as I said, I will be discussing separately. Now the apply command over here, right? So here, if you remember previous video also, I have discussed about the apply command, right? So we created our test model. So let us open another search window. Okay, so this time we'll take another 30% of ratio, okay, of the data. I'll have to select all time here. Okay, so I have total 133. Now I will apply that particular model for this new data set, right? It's a data set which we have not used for training. So apply. Now it's really up to us how we are using this sample to make sure that we are only using those data for training, and the data we are using for testing purpose is not part of training. Okay, you can make sure, as in this case I have used 70% and 30% over here. It may be possible that some of the events which is part of this 30% may be used for training as well, but as I am just demoing it, so I am not making sure of that one. But in real life scenario, ideally you should be making sure that one. Okay, so let us go back to our apply command. So will be apply command syntax is apply, then the model name, and then you can rename the output as well. So let us apply this model name first. So our model name is over here, test underscore model. So apply test underscore model over here, right? So in this case, this test underscore model will be applied on this 30% of data. That means it should create a new column called predicted chances of admit over here, right? If you see it, the model has been applied over here. Now if you want to rename it, you just give as some column name, let's say chances of admit predicted. Okay, so if you see, now it should rename that predicted, then bracket chances of admin field name with this meaningful name over here. So this is how this as input works over here. Okay, so let's move on. Next command is our summary command. Okay, now if you summary commands, as the name suggests, it will give you details about that particular model. Okay, now as this summary command works differently for different algorithms. So as we are discussing only linear regression, and our model is linear regression model itself, so summary will be giving me details about the linear regression details only for that particular model. To run summary, we'll just give summary, then test underscore model. So let's see. So this is how you can check the details of your model as well. You don't need to see your lookup files. So it's basically giving me all the coefficient, right? If you remember from my previous video or here as well, we have determined different coefficient for that particular linear model, right? So this is what it is giving me of the details. Okay, so this is how summary commands works in 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 clustering algorithm, or specifically the classification algorithm, which is also supervised in nature. It will give you for each and every class what is the coefficient value, similar way. Okay, we'll see that one in future as well. Okay, so let's move on to the list models command. So this is also another important command over here. So as the name suggests, so it will give you all the models you have created till now in your system. Okay, so if you remember from my previous video, we have created this particular model through this window, right? This experiments window. And today we have created test underscore model. So it is giving me two models now in my system over here. Okay, with all the details. So this is actually the content of the lookup file if you see it over here. Okay, now let's move on to our last command, which is called delete model. Okay, so as the name suggests, it will basically delete that particular lookup file from our system, right? So the model will be deleted from the system itself. So delete model. Okay, then the model name, let's say I'll delete the test underscore model. Okay, so the test underscore model will be deleted from our system. So if I just now do the list model, so it should give me now a single model over here now. Okay, so that's it, as it is. Okay, so this is how the different commands works in Splunk. And if you see it over here, the whatever things we have done it through training the model, right? While training the model, we can do the same thing over here using various search commands over here. And if you want to know what are the search command exposed in Splunk MLTK app, what you need to do, you need to go to settings, advanced search commands. Okay, select the MLTK app from here. Okay, and select created in app from here. Okay, so this will give you all the different commands name over here, and the command script file name as well. Now I will encourage you to see this file as well, how they have implemented. So these files will be existed in the bin folder. Okay, so if I just go to my Splunk home, etc apps, then Splunk MLTK toolkit, bin folder. Okay, these are all these different Python file. You can see it over here. You should see this code over here just to get a feel how they have implemented this model behind the scene. Okay, so hopefully this video is helpful to you guys. See you in next video.